the fundamental theorem of algebra. And the good news about the fundamental theorem of algebra is that we've already been talking about the fundamental theorem of algebra. We just have not given a name to it. So up here is the math definition for the fundamental theorem of algebra, and it says every polynomial, sometimes abbreviated P of x, of degree n, where n is greater than or equal to 1, has exactly n roots. In other words, what we're saying is, when we look at the polynomial, when we look at the highest degree term, that's how many roots we're going to have. So again, we've already talked about that. But as we look at our steps here, what we're going to do is we're going to find all the roots of x to the fifth minus x to the fourth minus 3x cubed plus 4 equals negative 3x squared plus 4x. Well, even before we put this in standard form, how many roots are we going to be looking for? 5. The highest degree term is 5, so we're going to look for 5 roots. But our first step is to put the polynomial in standard form, and luckily there's plenty of space on here. But as I write the problem down again, it's x to the fifth minus x to the fourth minus 3x cubed plus 4 equals negative 3x squared plus 4x. And what we're going to do is we're going to move the negative 3x squared over to the left side. We're going to move the 4x over to the left side, and we're going to write the polynomial in descending order. So we're going to add 3x squared to both sides, and I'm just going to do it in 2 steps because of space. But it's x to the fifth minus x to the fourth minus 3x cubed plus 3x squared plus 4 equals the 4x. And then let's move the 4x over to the other side. Again, make sure to write the polynomial in standard form, which means descending order. So x to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 4x plus 4 equals 0. So there's step 1. Put the polynomial in standard form. Step 2. Use the rational root theorem. There's our P's and Q's that we're going to use. And once again, a reminder that memory technique, quarter pounder, might be helpful. But we're going to list all the roots of P, which is just 1 and 2 and 4. All the factors of Q, luckily enough, is 1. And then our possible rational roots are P over Q, which is 1 divided by 1, 2 divided by 1, and 4 divided by 1. And they all could be plus or minus. If you look at your paper, the box now, however, says use your graphing calculator as an aid in step 2. That's going to help us here with our roots that we're looking for. Remember, we're looking for 5 of them. So let's type that function in to our calculator. X to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 4x plus 4. And let's look at the picture. The table is still good. I personally like the picture. Can we identify any roots in this picture? The answer is yes. We've got our root here, which looks like -2. We have a root here at 1. We have a root here at 2. But we can find right now -2 and 1 and 2. We can find 3 out of our 5 roots. But we need to use synthetic division for a couple reasons, which is our next step. Use synthetic division or long division if that's your preference. I left enough space to help us find our remaining roots. And in fact, we are going to have to use all 3 of those roots to help us find the remaining 5. So we're going to set up our synthetic division. And our numbers are 1, the number in front of the x to the 5th, minus 1, the number in front of x to the 4th, minus 3, the number in front of the x cubed, plus 3, the number in front of the x squared, minus 4, the number in front of the x, and our constant term, which is 4. And it doesn't matter which one you start with. Somebody has already told me that they would like to start with 1. It doesn't matter. So I'm going to put just a little check mark under here because we're going to have to use all 3 of them. So it doesn't matter. And now we're going to synthetically divide. We brought the first term down. 1 times 1 is 1. -1 plus 1 is 0. 1 times 0 is 0. And -3 plus 0 is -3. 1 times -3 is -3, and 3 minus 3 is 0. 1 times 0 is 0. -4 plus 0 is -4. And we better end up with no remainder, or else our answer is not a root. But 1 times -4 is -4, and we do end up with a 0, which is exactly what we want. Remember that we started with x to the 5th. What's the degree of our answer so far? It's x to the 4th. It's 1 degree less than what we started with. Well, we want to get our polynomial to where it's a quadratic. So right now we have x to the 4th. So we're going to divide again. And it doesn't matter which one of these 2 factors that we use. We do want to divide on our answer. So do we want to use -2 or +2? And it doesn't matter because we're going to divide with all of them. Okay. So once again, bringing down the first term from our division, we're going to take 2 times 1 is 2, and 0 plus 2 is 2. 2 times 2 is 4, and -3 plus 4 is 1. 2 times 1 is 2, and 0 plus 2 is 2. 2 times 2 is 4, and sure enough, once again, we get 0 for a remainder, which definitely proves that 2 is a root. But we started with x to the 4th. What's the degree of our polynomial now? It would be the x cubed. So we have one more root that we can use. We haven't touched the -2 yet. So we're going to divide one more time, this time by the -2. Again, the order does not matter. We're going to end up in the same place. So if you went and did a different order in terms of your roots, we're going to end up in the same place now. So we brought down our 1. -2 times 1 is -2. And 2 minus 2 is 0. -2 times 0 is 0, and 1 plus 0 is 1. -2 times 1 is -2, and positive 2 minus 2 is 0. Again, that's good. That proves that since we have no remainder, that negative 2 is a root. Question? Because what's the degree now? It's going to be x squared. We keep dividing because we want to put it here. Step 4 says repeat if necessary, and we had to repeat until we get all quadratic or linear factors. We're in quadratic. When we have quadratic, we can factor. We can use the quadratic formula. We know how to solve that. We don't know how to solve the x to the 5th. As we put our variables back in here, we have x squared plus 0x plus 1, which some of you may have even written just x squared plus 1. And we can solve this. And in fact, on this problem, we don't even need to use the quadratic formula, nor do we need to factor. We can get our remaining factors by subtracting, our remaining roots by subtracting 1 from both sides. So we end up with x squared equals negative 1. And when we solve this, we do the inverse operation of squaring, which is square rooting. So x equals plus or minus, what's the square root of negative 1? I. At the beginning of the problem, we said that we would have 5 roots. We were able to find 3 of them on the calculator. Negative 2, 1, and 2. And once we got our polynomial to a point where we had x squared as the highest degree, we found out that I and negative I were our remaining 2 factors. Same kind of thing on problem number 2 here, example number 2. We're going to follow those steps, and the first step is to put the polynomial in standard form, but before we do that, can we identify how many roots are we looking for? The highest degree of this polynomial is 4, so we're going to have 4 roots. So we're going to put this in standard form again. So we're going to move the 13x squared and the minus 10x over to the left-hand side. I'll do that in 2 steps just because I can't squeeze it all in one. So we have x to the 4th plus 2x cubed minus 13x squared equals negative 10x. And then we'll move the 10x over to the other side. So we're going to add 10x to both sides. And we get x to the 4th plus 2x cubed minus 13x squared plus 10x equals 0. Our polynomial is in standard form. We've got 4 roots. But before we can use the rational root theorem, we need to notice one particular, for lack of a better word, thing about this polynomial that's going to prevent us from using the rational root theorem until we deal with it. Well, if you look closely, what you see is a greatest common factor in here. Let's factor out the greatest common factor, which happens to be x. And then we have x cubed plus 2x squared minus 13x plus 10 equals 0. We need, for the rational root theorem, to have a leading coefficient, and then we have to have a constant term. 10x is not constant. But when we factor out the GCF, then what we have our quarter pounder, so to speak, a good memory technique for us. But even before that, what's one of our roots? X equals 0. And then we do have our x cubed plus 2x squared minus 13x plus 10. And if we look at our other possibilities here, again, we have the q and the p. The factors of p are 1, 2, 5, and 10. And by the way, you don't have to have them in that order. I know some people are writing 1 times 10 and 2 times 5. That's fine. We just want them all. And then q, luckily enough, is just 1, which means that our possible rational roots are 1 divided by 1, 2 divided by 1, 5 divided by 1, and 10 divided by 1, including the fact that each of those could be plus or minus. And this is what on the front page it says, use your graphing calculator in step 2 to help us. So if we come over here to our graphing calculator, and we'll clear out our previous function, and we'll type in x to the 4th plus 2x cubed minus 13x squared plus 10x. Notice that I didn't type in, oh, I did type in the original. I wasn't going to type that in, but oh well, I did anyway. So it doesn't matter. You could have typed in the x cubed one. The picture will be different, but the roots will be the same. What, did I type something in wrong? No, I got plus 10x. Did I write it wrong on... Okay. So, so as we look at the picture here, can we identify any roots? -5. Here's our 0, 1, and 2. So we're looking for 4, and we can see all 4 of them. But now we want to support our answer. So again, we're going to. So we had, what did we say, -5? 0, we already have 0. 1 and 2. So let's synthetically divide to support our work. Show all work to support. And what it seems is happening is we like to start with 1, which I agree with. I like to start with 1 as well. It's the easiest. And the, oops, I flipped over to the wrong page, but what we're looking at here is right here. The number in front of the x cubed is a 1. The number in front of the x squared is a 2. The number in front of the x is a minus 13, and then our constant is plus 10. Now we're going to divide. The nice thing is we started with x cubed, so we're not going to have to do very much long division. 1 times 1 is 1, and 2 plus 1 is 3. 1 times 3 is 3, and -13 plus 3 is -10. And 1 times -10 is -10, and 10 minus 10 is 0. So now, what we just finished with, when we divided, and sorry, I went kind of fast, is we finished with an x squared term. And when we get to x squared, that means that we can either factor or use the quadratic formula. X squared plus 3x minus 10. And luckily enough, maybe only for me, is we can factor. the factors of 10 are 1 times 10 and 2 times 5. Will either of those combine to be 3? 2 and 5. And which one's negative? And I hope that here, I know, I like to show all work to support your answer, but in terms of grading, I would grade the factor and I'd grade the answer. I hope that you don't have to show this. The x minus 2 equals 0, so we add 2 to both sides and we get x equals 2. There's nothing wrong with it. I'm just hoping that that's one less step that you have to deal with. When we subtract 5 from both sides, we get x equals negative 5. And I want to point out one last time. We said that we would have 4 roots. The first root we found by factoring out a GCF. And then we looked at our calculator and we saw all of them. But there's the one that we used to divide. And then to finish, we factored our remaining polynomial to find the 2 and the negative 5. There's all showing all work to support your answer. So as we finish today, one more time, f of x. We are going to find how many roots? 4 roots. And the nice thing is that the polynomial is already in standard form, so we can identify our p's and q's immediately. And here's the q and there's the p. So the factors of 18 are 1 times 18, 2 times 9, 3 times 6. And again, you do not have to list those factors in order. Q, once again, is 1. So my only regret now is that I didn't put a number in front of the x to the 4th. But it's 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1, 9 divided by 1, 18 divided by 1. And again, each of those possibilities could be plus or minus. We're in step 2. Use the rational root theorem to determine possible rational roots. Use your graphing calculator as an aid in step 2. Well, we know we're looking for 4. Let's type in our function. And it is x to the 4th plus x cubed minus 7x squared minus 9x minus 18. And again, I like to look at the picture. There's nothing wrong with using the table. Can we identify any roots? Negative 3 and positive 3. And let's use both of those. So this time we can't pick one, but we're still going to use our synthetic division with the 1 as the coefficient on x to the 4th, and 1 as the coefficient on x cubed, minus 7, minus 9, minus 18. We'd have to do them both. So do you want to start with positive 3 or negative 3, and it doesn't matter. We're going to do them both. I'll start with the positive. Carry down the first term. 3 times 1 is 3, and 1 plus 3 is 4. 3 times 4 is 12, and negative 7 plus 12 is 5. 3 times 5 is 15, and negative 9 plus 15 is 6. And 3 times 6 is 18, which works out well because negative 18 plus 18 is 0. we believe that 3 is a root of our function. We could see it on the picture, we could look at the table on our graph. We better get 0 for a remainder then. But we started on this problem with x to the 4. So our degree right now is x cubed. And we want to get this till we have a quadratic. So we're going to divide, again, by our other root that we found on our calculator, which is -3. We don't have to put the variables back in. It's going to carry the 1 down. -3 times 1 is -3. 4 minus 3 is 1. -3 times 1 is -3. And 5 minus 3 is 2. -3 times 2 is -6. And 6 minus 6 is 0. Now what we have is we have our x squared term. So let's put the variables back in. And we have x squared plus x plus 2. But as I'm running out of time here, normally what I would try to do is I would try to factor this. And then we would see that we can't factor it. And when we can't factor, that's when we need to go ahead and use the quadratic formula. And some of you have already been using the quadratic formula, and there's nothing wrong with that. But to finish, we're going to find our other 2 roots by using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Negative 1 plus or minus the square root of 1 minus 8 divided by 2. And that is negative 1 plus or minus the square root of negative 7 over 2. When we simplify the square root of negative 7, it's the square root of negative 1 times the square root of 7. What's the square root of negative 1? It is I. So this is negative 1 plus or minus I radical 7 over 2. And to finish, what we said is we would have 4 roots. The first 2 roots we were able to see on the calculator, the -3 and the +3. But ultimately we had to do the quadratic formula to find the remaining because we cannot see imaginary roots on our calculator. We end up with -1 plus I radical 7 over 2 and -1 minus I radical 7 over 2. I am fine if you want to write it with plus or minus, but if you're very literal, 1, 2, 3, 4 solutions to our polynomial.